Hi, sixth graders. We're on lesson 4-8. Our learning target is finding the least common multiple of two numbers. So we've talked about factors, and now we're going to be talking about multiples. So what is the difference between factors and multiples? Well, if we're given the number 12, okay, if you remember, the factors of 12 are the numbers multiplied together to get that number. So any number that, or numbers that we can multiply together to get 12. So the factors of 12, remember, are 1 and 12. Remember, we go from lowest and then our greatest would be 12. And then we know that there's 2 and 6 and 3 and 4. So those are our factors. These numbers can be multiplied by another number or a factor multiplied by another factor to get 12. Multiples, so you probably want to be writing this down in your notebook so you remember. So make sure you write out, I would make sure that you have factors of 12 down and then multiples of 12 down so you can look back and remember the difference. Multiples of 12 is basically like we're counting by 12. So we start at 12 and then we are going up by 12. So 12, 24, 36, 48, 60, 72, and so on. And the list goes on and on and on forever. So multiples are numbers, or basically 12 can be multiplied by a whole number to get a multiple of itself. So factors of 12 are less than or equal to the number. Multiples of 12 are equal to or greater than the number. Okay, so again, factors of 20 would be 1 and 20. If you want to pause me and try to figure this out yourself, you could totally do that. And then we have 2 and 10. 3 does not go in. 4 and 5 go in. Multiples of 20 would be 20, 40, 60, 80, 100, and so on. Okay? So if we want to find the least common multiple, the least common multiple is something that you want to write down in your notebook and underline it. And the definition is the smallest number that is a multiple of two or more numbers. So if we think back to greatest common factor, we took two numbers and we found the same factor that they both had, which was the greatest factor of each. Here we are looking at the multiples of the numbers that were given, and we're finding the least one. So the first multiple that we come to that they each have, basically. So there's two different methods. One is the list method. So write down the list method. And if you want to write all of this down, that's fine. Otherwise, we're going to be doing two other examples of finding the list method. But if we want to find the least common multiple of 3, 5, and 6, okay, we're going to list out the multiples just like we did on the previous slide. So the multiples of 3 are 3, 6, 9, 12, 15, 18, and so on. 5 is 5, 10, 15, 20, 25, 30, 35, and so on. And 6 is 6, 12, 18, and so on. Then we look in our list and we find the smallest number that is in all of the lists. So which we can see, and what is highlighted is 30 is in all of them, and that's the only one. So any number less than 30 is not in all of the lists. So we see 18 is in these two lists, but it's not in this list. 15 is in these two, but not in this one. So it has to be in all three. Now if we kept going, there would be other common multiples, but we are looking for the first one, or the least number. So the least common multiple of 3, 5, and 6 is 30. Okay, if we want to find the least common multiple of 6 and 8, so first we need to list out our multiples. So 6, 12, 18, and if you want to do this with me, that would be awesome. 24, 30, 36, 42. So sometimes it's hard to know how far to go out, but I would say if you do a good 6 or 7 for the first one, and then if you're going on the second one and you're going further and further and you go past this number, then you may need to go back and add more multiples. But for now, we'll just stop at 42. So then for 8, we always include our multiples. So 8, 16, 24, 32. And because I have two numbers, and because I'm noticing right now that they both have 24, and because we only have two numbers, we're only looking at two lists, I can see that they both have 24, and so that is going to be my least common multiple right there, because there's no numbers less than 24, and there's really no point for me to go on and on because this is going to be my least common multiple. So the least common multiple of 6 and 8 is 24. And then we always want to ask ourselves and double check, is 24 both a multiple of 6 and 8? Well, we know 6 times 4 equals 24, and we know that 8 times 3 equals 24. So then that works. Okay. If you want to pause me and try to do 8 and 18 and then unpause me and check, that would be something you can do in your notebook. So first we're going to list out our multiples, and we can kind of just look up ahead and see that we have 8, 16, 24, 32, 40, 48, 56, and I'm just going to stop there for now. And then I know that the multiples of 18 are 18, 36, 54, 72, 90, 108. I'm going to stop there. And as I'm doing this, I'm kind of looking up ahead, and I don't see any yet that have a common multiple. So I'm going to go back up and extend my list for 8 and see if I run into any of these numbers. So 56, and then we have 64, and then we have 72, which now I'm just noticing that they both have 72. So that would be our least common multiple. 8 and 18 both go into 72. So 72 would be our least common multiple. The second way to find the least common multiple is using prime factorization. So thinking way back to lesson 4.1 with the factor trees. So this is good review for you. So what we're going to do is we're just going to do that. We're going to factor it out and get our prime factorization of each number. So if we're doing 24 and 36, okay, I know that 12 times 2 equals 24. 2 is prime, so I'm going to circle it. And then I know that 6 times 2 equals 12. I'm going to circle my 2 because it's prime. And then I have 2 times 3. And then I have 2 and 3, and those are both prime. And I'm going to write it out as 2 cubed times 3. For 36, I know that we have 6 and 6 equals 36, and then 2 times 3 equals 6 for both. And they're both prime numbers, so we're going to circle all of that. Whoops, bad circle. Oh, another bad circle. Oh! So now I have 2 squared times 3 squared, because I have 2 2's and 2 3's. Here I had 3 2's and 1 3, so that's why they are written out like that. So this is the confusing part, because this is different than greatest common factor. So our next step is, so our first step was to do the factor tree. Our next step is to multiply the greatest number, or the greatest power of each number. So we are taking, so greatest common factor, we were looking for the numbers that were in common. This time we are looking for every number that is shown, I guess, in each of our prime factorization, but we are taking the number only once. So I'll show you a few different examples. So for this one, they both have a 2, but we're going to take 2 cubed because cubed, or 3, is a greater power than 2 squared. So I'm going to take 2 cubed, and then I'm going to take 3 squared because squared is a greater power than 1. Okay, so I'm just pulling out 1 2 and 1 3. So 2 cubed is 2, just to refresh our minds, times 2 times 2, and then we multiply it by 3 times 3. So 2 times 2 times 2 is 8, and then 3 times 3 is 9, so we get 72. So this tells us that the least common multiple of 24 and 36 is 72. 24, 48, 72 is a multiple of 24, and then 36 and 72 would be the next multiple, so they are both multiples. Okay, we are going to do another one. If we want to find the least common multiple of 5 and 15, well, we use prime factorization. 5 is already prime, so we're going to circle it and we're not going to do anything with it. 15, we know that 3 and 5 multiplied together gets 15. So the prime factorization of 5 is 5. The prime factorization of 15 is 3 times 5. Because remember, we don't include 1 in our prime factorization because 1 is not prime. Remember, our first prime number is 2. And secondly, anything multiplied by 1 is itself. So we just leave 1 out. So now we take the greatest power of each number. So the least common multiple, well, I can see that there's a 3, but there's only one 3. So we're just going to use that 3. Now I see that they both have a 5 and they both have the same exponent. So I'm just pulling out 1 5, and then I'm going to multiply them together. 3 times 5 equals 15. Well, 15 is a multiple of 5, and then 15 is a multiple of 15 because it's the first one. Okay, I want you to try this one on by yourself, and then come back and check it when you're done. So we are going to prime factorize out 10, which is 5 and 2. So, and then we write it in order. So 2 times 5, and then 12 is, well, I know that 3 times 4 equals 12. 3 is prime, 4 is not, so we keep going. 2 times 2. So we have 2 squared times 3. So our least common multiple, okay, we take every single number that there is, and then if there's a copy or a duplicate of the number, we take the greatest power. So that's where it gets a little confusing. So 2 squared is greater than 2, so I'm going to use 2 squared, and then I'm going to pull out the 3 because there's only one 3, but we have to use the 3, and then we use a 5. So if it was 2 times whatever, for whatever number it is, if it was 2 times 5 times 7 times 11, and 2 squared times 3 times 9 times 13, we would use every single one of those numbers. So it's just if there's more than one of the numbers, then we use the number with the greatest exponent. So I used a 2, so if there's more than one number, sometimes it helps to cross it off. So I got my 2 out, then I have to use my 3, and I have to use my 5. Okay? If, for example, there was another 3, 2 times 3 times 5, we would still only use this 3. Okay? We just have to use every single number that's used and then pick the one with the highest power. So 2 squared times 3 times 5, so 2 squared is 4 times 3 is 12 times 5 is 60. So the least common multiple of 10 and 12 is 60. Okay, we're going to do one more example. And I want to show you the difference between greatest common factor and least common multiple. So for both GCF and LCM, we are going to do prime factorization. So 25, the prime factorization is 5 times 5. For GCF, or for 30, the prime factorization we know is 5 times 6, and then we factor that out a little more into 2 and 3. So 25, we have 5 times 5. Okay, that's our prime factorization. For 30, okay, we need to write this in a different color so we can see it here. Okay, 25 is 5 times 5, so notice how I'm writing it out without exponents. 30 is 2 times 3 times 5. So they each have a 5, so we've used 5, but we only use one of them, and we pull that out. And then because there's not another 5, and there's not another 2, and there's not another 3, that is the only one that we get to use. But we only use one of them. We don't multiply them together, and this is where we get confused. So our greatest common factor of 25 and 30 is 5, because 5 is a factor. Remember, 5 can be multiplied by something else to get 25 and to get 30. Or 30 and 25 can both be divided by 5. Okay? For the least common multiple, which we just did, so if we have 25 and 30 and we just figured out the prime factorization, so for 25 and 30, okay, now I'm going to write it with exponents. So 25, the prime factorization is 5 squared. For 30, we have 2 times 3 times 5. Now we're going to use every single number that we see. Oops. That's supposed to say LCM. Okay, so we have 1, 2. We don't have any other 2's, so I'm just going to pull this 2 out. Okay? So we can even circle it so we know that we're going to use it. I see 1, 3. We don't see any other 3's, so we're going to use that 3. I see 1, 5, but I also see another 5. We're going to use that 5 with the greatest exponent, and we're going to pull that one out, which means this one gets canceled out. Times 5 squared. Okay? So we have 2 times 3 is 6 times 25. So the LCM, or the least common multiple of 25 and 30, would be 150. So hopefully that makes sense of the numbers from our prime factorization that we use for our least common multiple and what we use for greatest common factor. Notice greatest common factor is less than. Remember, it's a factor of it. Least common multiple is usually greater than, and it's a multiple of it. Okay? So something important to remember, you might want to pause this and write this whole screen in your notebook so that when you're looking back and trying to remember the difference between GCF and LCM, here you go. Okay? Do not forget to go into NICU and take the 4-8 NICU quiz. Have a super evening.